In section 6.4, we take a look at the central limit theorem, where instead of just selecting one individual and then trying to find the probability that that individual, whatever value we're looking for, is above some certain value or below some certain value or even between some certain value, this time we're trying to take a sample and we're trying to see if the mean of that sample is above or below or in between some values. So for this problem, it says, assume that females have pulse rates that are normally distributed with a mean of mu equal to 72 beats per minute and a standard deviation of 12.5 beats per minute. Complete parts A through C below. So for part A, it says if one adult female is randomly selected, find the probability that her pulse rate is between 68 beats per minute and 76 beats per minute. Now, in this part A, since we're only selecting one female, this goes back to the techniques that we saw in section 6.2. So just a refresher, let's go ahead and use Statcrunch. Okay, so go to Stat, Calculators, and then Normal. Let's go ahead and put the mean in. So our mean is 72, and then our standard deviation is 12.5. And now since we're trying to find the probability that it's in between two certain values, I'm going to click on between. And then let's put the values that were given to us. We have 68 as the lower bound and then 76 as the upper bound. We're trying to find the probability that if we selected one female, that her pulse rate is between 68 and 76. So let's go ahead and click on compute. And now this gives us the probability. So we have, round to 4 decimal places, we have 0.2510. Now for part B, this is how section 6.4 differs from 6.2. This time, it's saying if 25 adult females are randomly selected. So now we're selecting 25 females. We're trying to find the probability that they have pulse rates with a mean between 68 and 76. Now, the only adjustment that we need to make here is to the standard deviation. So we take the original standard deviation, which is 12.5, and then we divide it by the square root of the sample size. And now what's neat about Statcrunch, I could put SQRT, and then open up some parentheses, and then put the sample size in. Our sample size here was 25. So now this will take the square root of 25, and then it'll take the original standard deviation and divide it by the square root of 25. So this is one way to work it out. Since square root of 25 gives you a nice whole number, which is just 5, you could just put in 12.5 divided by 5 if you'd like, and you still get the same thing. Okay, so once again, you take your original standard deviation, which is 12.5, and put backslash. This is for divided by. And I put square root SQRT and put parentheses 25. Then I click on compute. Okay, so there it goes. So now the probability that if we selected 25 adult females and their pulse rates have a mean between 68 and 76, the probability of that happening would be 0.8904. So you have 0.8904. Now part C, why can the normal distribution be used in part B? Let me just make this bigger. Why can the normal distribution be used in part B even though the sample size does not exceed 30? Now remember, the conditions here is the original population has to be normally distributed, or the sample size has to be bigger than 30. Well, our sample size here is 25, but since we were given that females have pulse rates that are normally distributed, so their original population is normally distributed, that's why a normal distribution can be used here. So let's take a look at which answer choice that is. Looks like answer choice D. Since the original population has a normal distribution, the distribution of sample means is a normal distribution for any sample size.